We are recording, which is awesome. We are here to talk about databases. Hey, databases. So why, what, how, what is a database? So up until now, we've been writing JavaScript programs, Ruby scripts, C# scripts, nothing too crazy. We've been using React scripts to talk to an API. Everything we've done, all the data we've stored, has not been persistent. So what I mean by that is as soon as I run a file or I run a script, every piece of data, information that script generated, be it a sum in a calculator, be it the total for a finance app, displaying a picture, adding a person to a directory, everything like that, all of that has gone away once the program has stopped running. Right? You've been kind of working through a list. I need to add something. Then when I restart the app, it's gone. That's kind of how we've been working so far. Databases are a primary way to help fix that persistence problem. Because really, whenever we generate data, whenever we do something, we want to store it someplace. We can come back to it later. And that's where we put it. We put it inside of databases. And there are other places to store that data. We could put it in a file. We could put it someplace else. But really, a database gives us the tools, the power, and the guidelines and the structure of a place to really keep our data all in one place. So how do we do that? Well, we are going to be using what's called a SQL database to store our information. Has anyone heard of SQL before? Cool. Awesome. So what do we know about SQL? Let's just kind of start there. Open forum to the 4 people that raised their hands.
Structured query language, right?
Yes, it stands for Structured Query Language. Anything else? Yeah.
I thought it was SQL for a very long time.
Yeah, it's kind of a fun thing, like who pronounces it how. I say SQL.
I say both, SQL or SQL. It depends on if it's an initialism or an acronym.
Ooh.
Ah.
Yes.
I only learned that like a year ago. The difference between them. SQL being an initialism and SQL being an acronym.
Yes. Yes.
Whether you pronounce it or not. Both are fine.
Oh yeah. Yeah. Some people say like real developers say SQL, while amateurs say SQL, but 6 one way, half a dozen the other. But pretty much what that means, SQL stands for Structured Query Language. And pretty much it gives us, it's all about storing our data in a table structure that has rows and columns. And it's all about storing relationships with something called foreign keys and primary keys and joins and stuff like that. We're going to get to joins and keys tomorrow. But today we're going to say, hey, what is this SQL? What is a table? What's a column? And what's a row? So there's lots of different flavors of SQL out there. See, I'm already going back and forth, SQL and SQL. There's lots of flavors of SQL out there. There's Microsoft SQL, there's Postgres, there's Oracle, there's MySQL. Those are pretty much the big 4 ones. They're about 95% the same.
Yeah, they're all based around an actual standard, kind of like we have HTML and CSS standards. There are some standards. But just like anything, when somebody goes to implement a standard, you end up with yet another version of that standard, right? That's a great thing about them.
Is MongoDB similar?
So MongoDB is something, it falls under a different paradigm called NoSQL. So that we have SQL, which is very table, row, column based. NoSQL is any sort of database that stores data in not that format.
Yeah, you can think of also the difference between structured data and unstructured data.
Yep.
So you're going to see today the data we have falls under a very nice structure, right? Basically, a table with rows and columns. If your data fits that model very nicely, and we're going to see tomorrow with joins how we extend that to having multiple things related. If your data fits that model, SQL, SQL, language, and relational databases, which is the type of database that SQL typically gets implemented on, work wonderfly. If you have very unstructured data, meaning each individual set of data about a thing will be different, then SQL databases and relational databases are sometimes hard to use.
Mm-hmm.
And in those cases, unstructured databases or NoSQL databases like Mongo and there's a database called React that stores data in a very unstructured way.
Mm-hmm.
The world is still primarily structured databases
Yeah.
for the most part.
Yeah. So both technologies have been around for a long time. I actually just learned this today. NoSQL has been around since the 1960s. Who knew? But it really became popular in the past 10 years because of the sheer because the data we're collecting now tends to be unstructured. Social media data tends to be unstructured. It doesn't fit nicely into a SQL relationship. So just kind of to echo what Gavin said, like if the data fits into a table relationship, then that's awesome. But sometimes it doesn't, and that's where these other sorts of databases come into play. And MongoDB is one of those unstructured databases. It uses JSON and collections and documents to store everything. So primarily, the world is mostly SQL. It's a tried and true standard. All the big four implementations of those standards are pretty solid databases. So it's a very tried and true way of storing data and getting things done. So
and most of what we're going to teach you over the next 2 days in Postgres implementation of a relational database, that same knowledge will transfer to Microsoft SQL, will transfer to Oracle's MySQL and Oracle and many of the other SQL databases. Though you will eventually run into small differences that you're going to have to, in Microsoft SQL, the way we do this clause is slightly different. But like 92% of it will be the same.
Yeah, it's just like the syntax will be slightly different. Like maybe they use two ampersands instead of the word and for a conditional and. It's small things like that. Like where do my double quotes go versus single quotes. But like the ideas, the concepts, the key features are all going to be exactly the same. So as Gavin said, we're going to be doing Postgres today here. Postgres is an open source database that came about a couple years ago. I say a couple, probably 10.
And it came from another database which has been around even longer. It's one of these like long lineage database engines. It's probably one of the most popular, probably now the most popular, although maybe still kind of tied with MySQL, like open source database powering web applications.
Yes, yeah, it's powerful, it's fast. I think it actually overtook MySQL.
Has it?
Yes, at least feature set wise, and now offers more.
Feature set wise, it's always been. Kind of MySQL. I just wonder in terms of like deployment.
Actual popularity. Yeah. So Postgres is pretty much the open source decision. There is Oracle database, which is of course produced by Oracle. It's very popular. That's very enterprisey. If you stumble upon that, it's probably going to be a Java shop. That's most likely what it's paired with, but not all the time. And of course, there's Microsoft SQL, which is built by Microsoft. It says in the name. So yeah, we're going to be doing Postgres here. So in order for us to get going, let's see, intro to database. So in order for us to use Postgres, we need to install it somehow. So on a Mac, it's really simple. Brew install Postgres. And if you're on a Windows, you need to go download the installer.
Except both of them are using either Linux subshell or are purely on Linux.
Then it's probably apt-get
install
Postgres. Yep.
So Kenny, for you it'll be sudo apt install Postgres.
Does it matter what folder I'm in?
No, just be in your Linux subshell.
Is it apt or apt-get?
It's just apt.
Okay.
Apt, just exactly like that.
Okay.
And it may not be Postgres, maybe PostgreSQL.
Yeah.
Or both?
No. So Mac people
Just
brew
Postgres.
install Postgres. For you Linux folks,
It's Postgres.
Is it Postgres? Okay.
QL.
Sometimes it's Postgres, sometimes it's PostgreSQL.
It's PostgreSQL.
PostgreSQL, okay.
Mhm.
So if you do brew info Postgres for them, info Postgres. When you're done on the Mac, you should see something that's going to look like this at the end. Once Mark's brew wakes up, you'll see something like this at the end. So the database, unlike some of the other tools that we have, runs in the background silently. We don't tell the database where to store its files or how it's configured. You can, but for us, the default configuration out of the box works. So for the Mac folks, you're going to want your database running pretty much all the time. Otherwise, every time you start up an app that's going to use your database, you've got to tell the database to run. If you want to go through that, you totally can. So if you look at the bottom of your info when you end up installing Postgres, you'll see this line here that says brew services start PostgreSQL. If you run that, then on your Mac, every time you log in, your database will be running and happily waiting for you to do what you need to do. And you don't have to remember to start it and stop it and then like start your new app you're going to work on and be like, oh crap, my app's not working. Why?
Mhm.
Oh, I forgot to start my database. If you don't want that, then you can just run the second line, but you're going to have to run that every time you come back to your computer and start an app.
Yeah.
So I just recommend you just run it all the time. When it's not running, it takes up almost no resources, it takes almost no CPU, it takes super low amount of memory. I actually have like 4 different databases that I run on my computer constantly for like all the different kinds of projects I work on. It is not a problem.
Mm-hmm.
So I just recommend Mac folks, after you brew install Postgres, run this brew services start PostgreSQL, and you'll be good to go.
My computer is complaining about the sudo command. The app isn't working. Is there an npm way?
You're not running any Linux subsystem stuff, right?
No, I'm just running Windows.
Then you have to do what Mark had said, which is to download the Postgres.
Okay.
Could we set them up with the Linux subsystem?
You can.
I
I
think
have
that-
instructions. I have instructions in the handbook now.
Yep.
So maybe you want to follow up with him
Yeah.
this afternoon and see about getting that going.
Yeah,
if
I think
he
that would be
wants.
the easiest because I'd like to try that out.
Yeah. The
Okay.
instructions are pretty straightforward. And then the Linux folks, just installing that should start Postgres in the background automatically. The normal installer also has it auto-launched.
Okay.
If not, when we get going, if it's not running, then we'll look for the commands to
Yeah.
set it to turn on automatically.
Mm-hmm.
But I think modern Postgres install on Linux automatically registers itself to start at boot. Because why would you not?
That would make sense.
Did anybody, when installing Postgres, get an error? Or did anybody not see this line, brew services start Postgres? Cool. Congratulations, you are running an enterprise database on your computer.
Hey.
And
Woo.
in a second, we're going to see how to use it.
Yes. So now we are. I need to unfreeze that.
Postgres 11.1.
And actually, John, if you want to wait until this afternoon to install it, we can work through like the Linux subsystem, get everything going at once. So to use it, we're going to be using our terminal to actually connect to our database. Now, there are other ways to connect to a database. A quick Google search can give you probably a UI, but I always keep on coming back to the terminal personally because it's so straightforward to use and not behind a convoluted UI.
There's another good reason to learn the command line is, at some point, you're going to be sitting in your office. It'll be a nice Tuesday afternoon. Your boss is going to run into your office screaming, complaining that something in production is broken.
Mm-hmm.
And the way to fix it is you're going to have to log into the production server at some point and use the command line to connect to your database and go fix a Boolean flag to true that should have been false, or a 2 that should be a 3 on some table somewhere. And if all you ever know is the graphical interface, well, in the heat of the battle, you're going to have to learn how to use the command line. So the command line, while some people prefer the graphical interface, and I totally get it, always be familiar with the command line version of something, because when things are on fire, the command line is always going to be there for you. This is why we teach you the Git command line before we show you the VS Code click on the icon, type in a message, click the checkbox, because you'll always have the command line available to you.
Yeah. So in order to connect to a database, we need to first off create the database. That's kind of our first step one. So the command to create the database, create DB, and let's call it, I want to make a database of books. I want to be able to store a list of books on my computer. So I'm going to call it book collection. But not camel case. Book collection. Because that is so I'm using snake case here because that's the case that Postgres likes to work in. Is that correct, Gavin?
I think so. Yeah, I don't think Postgres cares, but it's not usually capitalized.
Yeah.
It's either underscore or dashes, but I think underscores prefer.
Yes. Yeah. So for today, .NET folks, we are going to be doing snake case stuff.
Yeah.
So I'm going to create it. No feedback. No feedback is good feedback.
So I'm waiting for someone to ask the proverbial question. Hey, Mark, does it depend on where I run this command?
It does not. It does not depend on where you run this command. You can run this in any directory, anywhere else, because Postgres is another service that's running on your laptop. It's not project specific. It's its own thing. I see two hands shooting up in the back.
I could not connect with that template.
So your database is not running. So you should do sudo service start PostgreSQL.
It's nice in here.
No. Yeah. Just try Postgres without the QL. Try use
Hi.
service.
I closed my terminal, and is that bad?
Nope.
How do I get started again? Because it doesn't work using that.
What's the error whenever we use that?
Bash created command not found.
On create DB?
Oh, let me try it one more time. I think I got it.
Did you misspell it?
It did nothing.
Yeah, it should do nothing.
It's good.
No,
Yes.
no feedback is good feedback
Okay.
because that's what developers like.
It's also one of the reasons is a lot of times we run these commands. Other commands will be processing the output of the command.
Yep.
So there are a lot of tools that will run create DB for you. So what they're looking for is did create DB spit anything out, and anything it spits out will be the error. So silence is golden.
Mm-hmm.
Right? So that's why a lot of tools don't give you any output when they do the right thing. Like when you cd into a directory, you don't get any output. You're just in a different directory.
Mm-hmm.
If you just created a database, you didn't get any output, but the database exists.
Yep. And there are some tools that you can get on your shell. So you see that green arrow that I have on mine? That means that the last command was a success.
How do you add that?
This is something called Z shell that I put on my terminal. It's a wrapper around the terminal. So like if I fail a command, my arrow is now red. So it's just a little more feedback like, oh, wait a minute. Why is it red? What went wrong? Oops. So yeah, so
It's the other way.
we created. How are we feeling so far? The ones that aren't having technical issues.
Yeah,
Feeling-
split the start and the PostgreSQL.
Feeling good? Okay.
Sudo service,
So now I want to connect to my database, my newly freshly created book collection database. In order for me to do that, it's going to be pSQL, and then what do I call it? Book collection.
Book collection with a underscore snake case.
Book collection. So this will give me a new terminal that allows me to type in SQL statements. So now I've actually connected to my database. Should we show them PGCLI today?
We should.
Okay.
Let's start with pSQL, but then show them PGCLI just so they can see
Okay.
the difference.
What does the number represent?
So that number is the version, 10.5. Your version might be different. I don't know
Yeah,
what
just
Liz
might
is.
say 11.
Yeah, which is fine.
Still hanging back there. The version of what?
Postgres.
Oh, okay.
So you've downloaded, and if you run this command, I'm being told it's 11.1 now, not 10 point
So
something, so I should
you are
update mine.
running, let's just say,
And now what this is now a REPL for SQL commands. So we talked about a REPL before, right?
Could you define it again?
REPL, read, eval, print loop.
Okay.
So it's a place where we can type commands, they are evaluated, and it prints the result. So like on Monday, the Ruby folks were introduced to IRB, right?
Yes.
Where you can just start typing IRB and then start typing Ruby commands one at a time. That's a REPL. In JavaScript, we have the node command, right? I can type node, and now I can type JavaScript, right? I can type in, it will read my command, it will evaluate it, it will print the result, then it will loop back again and start again. You know, the terminal itself is also a REPL. Get rid of this. So now this is a REPL for SQL commands. And I almost feel obligated to wait a little bit. See if we can get that caught up.
Read, evaluate, print, loop.
Correct. The reason why C# doesn't have one or doesn't have a good one yet is because it's a compiled language. So languages like Python and Ruby and JavaScript that are interpreted, they don't need, they can just kind of run commands, just kind of go with the flow. But C# does a whole bunch of checking, so it can't be compiled. There are some C# REPLs out there that do some magical things, so it is possible.
So like when you type node, that's a REPL.
Yeah, that's a REPL for JavaScript. There's also a REPL in your browser for JavaScript. I don't know if anyone's tried that out yet. In the web tools, you know how there's a console where all your errors show up? You can also type in JavaScript commands there and run stuff there. So that's also a REPL. Any other thoughts so far?
I have a question. So
Yeah.
we have book collection.
Yep.
We can make as many as we'd like.
Many databases?
Yeah.
Yep.
Or you just name. Okay.
Yep. So as many as you like. I will say that you are of course constrained by the size of your hard drive. You know, but that being said, if you're actually hitting the size of your hard drive, you're probably doing something very, very, very wrong. Storing a lot of data, especially here. There are some databases that will get kind of big, but those are like production databases that are logging everything that have been working for years.
So if you're running this in your background,
Yep.
It's going to, in the background, run every database you've created.
Yep. And then you can just kind of connect to it.
That doesn't slow things down.
Nope. So we're PSQL, right? PSQL -L. You can run this command and actually list out all the databases that you have. So as you can see, I have a few, not a lot, but a few. Each one of those is its own database.
Delete me.
Yeah. These two are my favorite. Delete me and dumpster. I don't know what those are, but I'm sure they're useless.
What was the command again?
To see this, it is PG CLI. Sorry, I lied. PSQL -L. So if y'all run this command, you should actually see one database, maybe two. No, I think it's just one. A few, maybe a few.
Mine says fatal.
Oh, that's always a good sign. Did you leave PSQL first?
Yeah, -L.
So let me show you this. So you were on this screen, right down here,
No, maybe that would probably.
because you shouldn't be. You should be anywhere on your terminal.
So there were a couple extra commands for our Linux friends that we
Oh.
got going.
Okay, sounds good. It's on my databases.
Ooh,
Yeah,
so many databases.
so it's just kind of filling time. We had a question like, how many databases can we make, and do we care about how many?
Nope.
Like nope. Especially in your dev environment, databases are typically smaller, so you really don't have to worry about it.
Until you're doing something like, hey, dump all the production data and restore it on your local machine.
Yeah.
If you've got, a terabyte of data in production, maybe you care about your machine.
Yeah.
And what you'll find even in those situations, your job will have some task that will take a sampling of production data and export it from your production environment and import it into your development environment.
Yep.
But even those data sets tend to be relatively small.
Mm-hmm.
So you've got plenty of space.
Oh yeah. So now that we're all good here, to connect pSQL book collection. So here is where I can now type SQL commands in order to work with my database. So the very first thing we need to create is something called a table. Now a table is a place where we're going to store our data, and it's tied around an entity. And Gavin is going to go there.
I'm just gonna make sure that Kimmy's doing all right.
Okay.
Did you get caught up?
No.
I was going to start erasing stuff. Hopefully y'all
You
didn't.
need to do the same thing.
So a table is a place, it's something that we store our data in. A table has a name. These names are usually the nouns that are inside of our system. So when I say nouns, these are the entities, these are the things that I care about. So here in my book database, what's my nouns?
Books.
Books, yes. So we're going to name our table books. Now our table has rows and columns. Our rows are the actual individual data points that we have. So if I insert 3 books, I'm going to have 3 rows. Our columns are the details that we're storing about each book. So, for example, what do I want to store about a book?
It's time.
Its title. What else?
Author.
Author. What else?
Publication.
Yes. Publication. Published.
Publisher.
Publisher.
Publisher. Should be good enough for now. So that's a 4-column table. So what we're starting to draw, you notice how I started to write it in more of a list, not really columns. What we're starting to draw here is something called an ERD. An ERD is a graphical representation of our database. It's going to have what tables we have, what columns each table have, and also the relationships that are stored between the tables. Because really, in a database world, it's like, yeah, we care about the data, we're storing it to store the data, but we as developers don't try to think of the actual data specifics yet. We haven't thought like, oh, I'm going to store Lord of the Rings, I'm going to store The Cat in the Hat. So no, I was like, I just care what I'm storing about those books and what's the structure of that table. So we like to use ERDs to help communicate that to each other.
What are rows again?
So rows are the actual data points.
Actual data points. And is this data?
This is the structure of the data.
Structure of the data.
Yes. You can almost think of this as kind of like an Excel spreadsheet. Are you familiar with Excel? I would assume. How it's like, oh, we have, if we were in Excel, we'd have a column for title, we have a column for author,
Right.
So
I
forth.
was just confused because you made them rows.
Exactly. That's kind of the weird thing about the ERD, that this is just a way for us to communicate what we're storing.
What does ERD stand for?
Entity relationship diagrams.
So
Okay.
they are actually columns?
Yep.
Right.
Okay.
Just visually, when you're making your little boxes of your diagram,
Yeah.
Mark could have written books and then written out this way, right, horizontally.
Yeah.
What tends to happen is your databases tend to have very, very many columns, right? Well, you don't want to have too many, but
Yeah.
you have enough that writing them out horizontally is just visually better to write them out vertically. So
So
we have books, and we're going to sort of title, author,
publish date and
and
publisher.
publisher. Cool.
Yeah,
Nice.
it's always good. So now, not only do columns have a name, so like title, author, publisher, date, publisher, they also have a type that is associated with them. Like C#, like some other languages we have, we need to say, hey, what type of data are we storing inside of this column? So let's kind of give these things some types based on the JavaScript types that we know of. We can kind of massage them into what's the Postgres equivalent. So a title is probably going to be type string. Author is going to be published date. Date.
Could also be indents. We'll talk about that later.
Yeah, we'll probably change that to a published year whenever we actually get the coding and stuff, just to make things a bit simpler for us. And publisher is going to be any other data types or any other columns you're thinking about, Gavin?
What about if we had a column called in stock?
In stock.
What kind of type would that be?
Well, is it the number you have, or do you have it or no?
How about I call it, is it in stock?
So Boolean.
Yeah.
Number of pages.
Yeah, number of pages.
There we go. And number.
Just trying to think something that was a Boolean.
Which would be a number, right? If we're in JavaScript. So
Hey Mark, what if we wanted all of the chapters, the titles of all the chapters in the books?
Yeah, I was wondering about that.
An array.
Right.
right.
So that's one of the things we tend not to have as a data type.
Mhm.
So we're going to have to put off storing the chapters of the book until tomorrow. Right? That's where we get into relationships. Right? So you'll find that the columns of things in a table tend to be singular. Right? It's the title of the book, it's the one author of the book. What are we going to do if there's two different authors? Right? We're not going to store, Gavin, Mark in that single string. Right? So when we say author here, we can only support one author. Right?
Publisher.
Yeah, same with the publisher, right? There's only one. What if there were multiple releases of this book? It was published in different editions on different dates.
Mhm.
Right? This is where those bits of information, informations, are going to be in separate tables, and then tomorrow we're going to learn how to relate them together. So what tends to happen is in a single table, the columns tend to represent singular things. So there's a little bit of a lie in all of that I just told you, is that modern relational databases do now support an array type.
Mhm.
So only in maybe the past
That's a really
5
recent thing.
to 7 years or
At
so.
most, yeah.
Yeah, now have the ability to have multiple array, so you could have authors as an array of strings.
Mhm.
Right? It's not part of the SQL standard yet, so databases who do that are adding extensions beyond the normal SQL, but you will, if you happen to Google Postgres and arrays, yes, Postgres does support arrays. But things like MySQL, its major open source competitor, has only supported them very recently because it's an extension to the normal SQL standard.
Are they going to add that to the SQL spec?
I don't know, it may already be in there. I haven't looked.
Okay.
The
Yeah.
last SQL spec I know is SQL 92,
Okay.
so it's a little old.
Yeah.
I'm curious to see if it's in there. I don't know if it's actually officially in there.
Okay. Yeah, that's one thing I probably should be better at is reading the SQL spec.
Yeah. When you tend to see these types of things in the wild,
Mhm.
they tend to be singular data things.
Yes.
And you tend to store multi-things in separate tables, and then tomorrow we're going to learn how to relate them together, right? Because that's the key word of relational databases. We're storing these things so we can relate separate bits of data together.
Okay, so that's fine and dandy. We have our tables. We're just going to store that today. So let's go ahead and let's create this table for us. This is going to be our first type of query. is going to be a create query, a create table query. So here we are inside of our REPL. We should see that we are connected to our database, and that equals hashtag means that it's waiting for a command. So we're going to type in create table. We'll call it books.
Do we get do in caps?
So that's a great question. Postgres SQL commands are case insensitive. So you could type it in that crazy SpongeBob format if you really wanted to. You can type it all lowercase, all uppercase. It doesn't matter. But good programming practices, and the common thing you'll see is the SQL commands themselves will be in all caps. And the actual like column names will be whatever the database is appropriate. Here it's going to be a snake case kind of thing. Yes, question.
I have collection equals hash, and I also have dash equals hash. I was trying to do the list like you showed me.
Ah, I see what
That
happened.
command, the pg-cli-ls, only happens outside of pg-cli. Once you enter the pSQL, you're in the pSQL rep. That's a command ls, and those things you would do from your bash shell.
Okay.
So once you're in pSQL, it's like you're in Ruby, so you can only type Ruby commands. Here you can only type SQL commands. So those commands were rejected.
Okay, but am I okay here? I don't have an equals hash.
We're not done with this command, so don't run it yet.
Okay.
Can I get rid of it?
So if you ran this command, what happened is that you're probably stuck to something like this, right?
Yeah.
Where you have the minus hashtag. That's okay. It's waiting for more of the command. Do you know how in my terminal I had the green and red arrow? It's kind of like green arrow was success, red arrow was failure. This is kind of the same way. If you see the equal sign, that means it's ready for a new command. If you see the hyphen here, just the single line right there, that means that it's waiting for you to continue the last command.
If you want to start over, you can type Control-C and get back to the equal sign.
Just like that.
And that will stop that. And if you want to type it all on one line like Mark is going to do,
Mm-hmm.
Control-C will get you back to a brand new command.
Yeah, because I actually didn't even have equals the first time. I did PSQL-L.
Mm-hmm. You tried to run it inside of here.
Didn't do anything. Yeah.
Yep.
Right? You probably
So-
tried to do what Kenny had done, is run that pSQL-L command inside of
Right.
pg-cli.
Exactly.
Or pSQL, right?
Yep.
So this is like trying to type terminal commands inside of IRB, right? We are not in the terminal.
Right.
We're not at our shell. We're not at our prompt where we can type ls and cd and yard start and all those things. We're inside of pSQL, right? Like we can't type like npm install. Like that command doesn't work here. We're not in the bash shell where we can type those things. We're inside of the pSQL. So we can only do pSQL style commands.
Is there a clear now that I've done that?
Command K.
Command K.
That's the parentheses.
Yeah, he's gotten himself into a weird state because he was typing random things.
There we go.
So Control-C will get it back.
There we go.
Right.
Yep.
So if you want to go back to your shell, you can do Control-D.
Nope.
Really?
Really?
You've got that mapped to
Oh, Command.
Command-D.
There we go.
Control-D. Quit those extra. You probably did Command-D, Control-D. What? What's happening?
So.
You did a screen split.
Yep.
In the right-hand corner is the close, I think.
There we go. All right. So I'm actually
And
going
you
to.
closed your whole. I think you closed that whole terminal.
I did. So PG pSQL
Collection.
book collection.
Right.
So here we are. Back to this. So equals line hash. It's ready for a command. Create table. We'll call it books. And now we're going to open up parentheses. Now we're going to type a comma-separated list of the columns and the types. So we have title. And now we said it's type string, but in Postgres it is type text. We have author, which is also type text. Come back here. We have published. Published. Year. We'll make it year. And since it's just a year, we can store it as a number. Our numbers are ints, I believe, if I recall off the top of my head correctly. Publisher is a text. Is in stock is a bool, I believe.
I think that's right.
Do I have it in my notes? I do not. Bool, and then number of pages
Number of pages.
would be an int.
Can you do floats?
Yep.
Yes.
Yep. There are. It's the decimal type. And you can actually specify how precisely that you store them.
So you all were having a discussion about how imprecise floating points are.
Mm-hmm.
So you might think like, what if we wanted to have something in here about the cost of the book, right? Like we want the cost of the book to be $9.99. So you might think that the way to store that is as a decimal. You're wrong. You should store that as an integer number of pennies. Because math in computers, anybody see Superman 2-1, right? Where Lex Luthor's plan was to like, or one of the plans was like to round off all the fractional parts of pennies and
Isn't
transactions.
Isn't that Office Space?
Office
But it was
Space.
also from Superman. It was also in Superman.
Oh,
That was
okay.
the root of it.
Yeah.
Office Space.
So you might think decimals are great for storing things like money, but what most projects do is store them as an integer number of pennies.
Mm-hmm.
And then you do the math to show dollars and cents in your application layer. Because it will work, but then you'll start to add two numbers together and you'll get like $10 and 23.00001
Yeah.
is the cost. So yes, decimals are here, but they tend not to get used very much unless the data itself is decimal style data.
So like latitude and longitude, if you're storing that, it's probably a decimal style.
Mhm.
Though I think there might actually be a geo point in Postgres, I
Mhm.
believe. Yeah. But like stuff like that, stuff that's non-money but still decimals, perfect for a decimal.
Yes.
Financial systems really care about stuff like that, as you could probably imagine, because like fractions of a penny matter to people, as it should. But yeah, data types, Postgres. This is not the official docs, is it?
No, that's supposed to be a tutorial, which is actually a pretty decent site.
Yeah, this is a
That's
great
not the-
site for
That's
it.
not the official documentation. There's the official documentation. That's
Yes.
for 9.5, it should be good enough.
Yes. Current. So like here's all the different data types that we have.
Look, they have a money type.
We do have a money type. Though I don't know if I'd use it because it's location sensitive.
Yeah, and I think it's probably also an extension, not part of core
Yeah.
SQL.
Yep. Yep. So, but
They have a type, but they say it's not recommended.
Yep.
Nice.
so it's there for you to use if you go against the recommendations.
Binaries, booleans, enumerated, geometric for points, lines,
Mhm.
boxes, circles. If you're doing geographic stuff, right?
Mhm.
It's like points on the surface of the earth.
Yes,
Networks types. Here's our
that's kind of cool.
text types.
Yeah.
XML, JSON, arrays. Back to our question about arrays.
Hmm.
Composite types, range types. But a lot of these are things that Postgres has added on top of the standard.
Yeah.
So, it's the kind of thing that it's awesome to learn, but you're going to learn Postgres' way of doing geometry type things, and then you're going to switch jobs to one that's using MySQL, and you're going to have to learn their way of doing geometry
Hmm.
because it's outside of the standard spec. But Postgres is kind of famous for having advanced and good support for data types,
Oh yeah.
and that's why it got very popular because without these things, it gets
Yes. So yeah, here's my table. I've created my statement. I said create table, call it books. Here are the columns with their data types. Now to end my statement, semicolon.
Semicolons.
That semicolon's super important.
Yeah. SQL loves semicolons.
Yes. And I should, in theory, get this back, create table. And it's ready for the next command because it's equal hash. And here we are. How are we feeling with this command? Did we run it?
I misspelled Belgium.
Okay, that'd be an issue. So now how do I see what I just made? Well, -D, that'll give me a list of all the tables inside of my database. Right now, I only have one table. It's called books. But now how do I see the actual schema of that? And that's a new word, schema. Schema is a fancy word for the structure of the table, the structure of the database. So our ERD is our schema for our database. People throw around the word schema like it means something else, but it's pretty much a fancy term for structure. So here we are. I want to see the actual schema of the table that I created. So it's -T, then books. You see, that will give me something that looks a lot like our ERD. It has all of our columns as well as their data types. So it is 10:54. Let's take a quick 11-minute break, come back at 11:05. And whenever we come back, we will look at how to query and how to actually use our table and actually explore the SQL language itself. So we'll take a quick 10-minute break.
First command in our third language.
Yeah.